So, what questions do you have from the test? Number 10. We are expected to find the exact value of the tangent of 13 pi over 12.
You said number 10?
I did say number 10.
Oh, yeah.
So, what do we need to do?
Find something that adds up to 13 pi.
Yeah, we're going to need to turn 13 pi over 12 into something plus something with denominators of 4 or 3 or 6 or 2.
I did 9 pi over 12 plus 4 pi over 12.
9 pi over 12 plus 4 pi over 12, which would equal 3 pi over 4 plus pi over 3. That has those denominators, so that could totally work. So let's turn this into the tangent of 3 pi over 4 plus pi over 3. Now what do we need to do?
Use the tangent sum.
Tangent sum identity. What does the tangent sum identity look like?
Tangent theta plus tangent theta over 1 minus tangent theta tangent theta.
Alpha times tangent beta. Great. So we turn this into the tangent of 3 pi over 4. The 3 pi over 4 is one of the things that threw us off a little. Plus the tangent of pi over 3 over 1 minus tangent of 3 pi over 4 times the tangent of pi over 3. Okay. So the tangent of 3 pi over 4 is one of our mistake plays. Another mistake was not to use this identity at all. That was a possible issue. So where is 3 pi over 4? Quadrant 2. Tangent is what in quadrant 2? Negative. So this evaluates out to a negative of whatever it was, right? And so that was definitely a mistake I saw on this one. So what is the tangent of 3 pi over 4?
Well, pi over 4 is 1/2, so negative 3/2.
Tangent of 3 pi over 4 is not 1/2. It's definitely not 1/2. It's the square root of 2 over the square root of 2, which would be what? 1. So it would be negative 1. Tangent of pi over 4 is 1. It always has been.
No, it's 1/2.
It's definitely not. Look it up in the book or your notes. It's definitely 1.
That's okay. I put 1/2 too. Don't know why though. Makes sense that it's 1.
If you want to do it from a triangle, I'll show you just for further clarity. We're talking about this triangle. 1 over 1, which is 1, yes. Okay, what is the tangent of pi over 3?
Square root of
Square root of 3.
Plus the square root of 3. And then 1 minus negative 1 times the square root of 3. In the denominator, we got a ka-chink moment. We got -1 plus the square root of 3 over 1 plus the square root of 3. What do we need to do now?
Isn't it gonna be 2 on the bottom though? Because you're adding rows.
You are not. Order of operations. What do we got to do now? Rationalize the denominator. That's true. So we're going to multiply times 1 minus the square root of 3 over 1 minus the square root of 3. In the numerator, we've got -1 times 1, which is -1. -1 times negative square root of 3, which is plus square root of 3. Then we've got square root of 3 times 1, which is square root of 3. Square root of 3 times negative square root of 3, which is -3. Denominator, just do the first and the last. So 1 times 1 is 1. Square root of 3 times negative square root of 3 is -3. So in the numerator, we have -4 plus 2 times the square root of 3 all over -2. We got to do one more thing right now. What do we got to do? We can reduce, right? And turn it into 2 minus the square root of 3.
Wait, wouldn't it be square root of 6 minus 3?
No, because it's the square root of 3 times the square root of 3, which is square root of 3 squared, which is 3.
No, over plus square root of 3.
Square root of 3 plus square root of 3 is 2 times the square root of 3. It's not square root of 3 times the square root of 2, which would be square root of 6, right?
Are you taking out when you're reducing it, is it taking out a -2 or is it taking out a +2?
I took out a -2, so the negative's in the middle. If you wrote the answer -2 plus the square root of 3, you would also be right. Because we can flip all of the signs. Actually, would you? No, you would not also be right. That's a lie. This would not be right. Because you'd be left with a -1 in the denominator if you did that. Because then it would not be that.
You could do that, you just have to do extra steps to get the...
Yeah, and then you'd have to get rid of the -1 as well. Yes. Yes. Okay, go for it.
I was ready. That's a great picture for it to be in my camera.
All right. What other questions from the test do we have?
4.
One of the better side. Yeah, 4.
4 is the one of the two of those that is difficult. More difficult, I should say. We've done worse ones, but that is probably one of the harder questions on the test, I imagine. There are quite a few steps to that problem. Number 4. Like all of these type of problems, there's who knows how many possible ways to solve it. Lots. I feel like this one at least kind of gives you like, yeah, I probably should start here, which is sometimes a red herring and you end up going down a stupid path. But, squared theta over, is it secant, right? Secant squared theta. Secant squared theta. We're supposed to verify that it works. So, what could we do?
If the one on the left is a...
Oh, it is, and that should be a 4. It is a difference of squares. Let's do that. So let's turn it into the cosine squared theta plus sine squared theta. Yay, that's a happy one, yes. Cosine squared theta minus sine squared theta. That's less happy, but So what can happen right now?
Something on the left turns into 1.
This one turns into 1, right? Easy peasy. Pythagorean identity. So now we've got the cosine squared theta minus the sine squared theta equals still all of that mess, right? Now's where we start being like, okay, we could go a lot of different ways. What could we do?
Secant squared theta. Isn't that just, since it's in the denominator, wouldn't it turn into cosine in the numerator?
If you want to do it that way, sure. This is not the path that I walked down, but let's do it. It's not illegal. The one thing that you have to be careful about is the fact that this is all of this will be times cosine squared theta. That's true. They at least kind of got rid of some fractions. Sure, why not?
Also, the secant squared also equals tangent, or 1 plus tangent squared.
It does. That's true. What else could we do?
Well, if... No, never mind. Just kidding. Well, if secant squared of the angle turns into 1 plus tangent squared of the angle, I feel like there's something that you make that helpful.
Something that can make that what?
Helpful.
Okay, let's walk down that path too. Tangent, 1 minus tangent squared theta over 1 plus tangent squared theta. Sure. Maybe so.
They won't have to calculate the distance from Earth to the Sun, then use that answer. They'll have to calculate the mass of black holes.
Is that the same? Is that the same?
Yes, it is. Okay. So we've got some variation of something useful. What could we do?
You can change the stuff on the right into their identity,
On the right,
the left.
the left,
The left, because it changes into, I don't remember what they're called, but
the Pythagorean identity?
no, the power reducing.
Oh yeah, you could do power reducing, but nothing else is power reduced. So we'd have to like start doing a whole bunch of power reduction stuff. So yes, you could. That feels like a lot, adding a lot of junk. And so probably not. I can see a couple of different paths forward. Neither one of these are the direction I went on the key, but they both, either one of them could get us there, theoretically. So we have this equals that, or if we prefer, this equals that. Either one of those.
Does the stuff on the inside of parentheses, is that equal secant?
It doesn't, because 1 plus tangent squared theta equals secant squared theta. So no, it doesn't equal secant squared theta, unfortunately. Because then we just have to figure out how the other side equals 1 mysteriously, which it doesn't. So then maybe it wouldn't be good because it would all break.
Can we divide everything by -1 and then the stuff on the left equals 1?
It doesn't. It doesn't because it would also flip that sign. So right now we have 3 different trig functions. What if and we got a bunch of squared stuff. So what if we try to turn some stuff into some other trig? Let's get rid of some trig functions. Let's make some things something else. Let's do one of those things. Sure. If we're going with this one, definitely turn that into sine and cosine. Maybe this one. Which one do we want to go with to start? This one or this one? The right, turning tangent into sine and cosine. Great. So the right-hand side in this instance will turn into 1 minus sine squared theta over cosine squared theta all over 1 plus sine squared theta over cosine squared theta. Great, maybe. Now what?
Can I keep, change, flip, and multiply them?
Yeah, turn them into, well, we had to combine fractions first, and then the keep, change, flip, right? Right? Because so we'd have to turn this into the cosine squared theta minus the sine squared theta. Oh, that looks like the left side, so that's promising. Over the cosine squared theta over cosine squared theta plus sine squared theta over the cosine squared theta.
And this was what?
That's just combining these into single fractions. This numerator here, cosine squared times 1, and adding the numerators together, cosine squared minus sine squared theta. Right? Same thing in the denominator. So, miraculously, because our keep, change, flip turns this, like when we flip this over, and the cosine squares cancel, right? Right? Cosine squared plus sine squared equals 1.
Wait, did we just do it?
We just did it.
Absolute freaking magic.
That's why I like these problems. Okay, what other questions from this test do we have?
Did y'all have problems with 8 or 9?
I have problems with everything, so anything will be helpful. I had problems with 8, that's for sure.
Problems with 8. Sounds great, let's do 8. 8, y'all didn't heed my warning, but there was a lot to remember, so that makes sense. It wasn't like intentionally you were ignoring me, you just didn't remember. At least some of you, that's what happened.
What was your warning?
My warning was that if you just start dividing and poofing stuff away, you're gonna accidentally kill off some numbers.
Well, the thing is, I had one answer more than I was supposed to, so.
Actually, you didn't have enough answers. One of those was wrong. I think, did you look at your notes? Because I like circled some stuff on what happened in yours, but I always, well, not always, but often do that. So number 8 from the test was sine squared x equals 1 minus cosine x. Now what? We're supposed to solve for all values of x.
The one on the
Left?
left.
Yeah.
No.
Yes.
The one on the right equals 1.
No, it doesn't. If it was squared, it would, but it doesn't. But it's not.
That's what my mistake was.
Well, there you go. Magic. The one on the left we can change, which will be useful.
1 minus cosine squared x.
1 minus cosine squared x equals 1 minus cosine x.
That equals 1.
It's not equal 1. Sine squared plus cosine squared equals 1.
Can move everything to one
Oh, okay.
side.
We could move everything to one side. I agree.
And that's where I messed up.
You probably messed up the SIG in somewhere. I don't really remember.
I hate sides.
These are not like terms. You can't combine them. Can't happen. These do cancel, which is nice. So we end up with negative cosine squared x plus cosine x equals 0.
Take out cosine.
We could, or we could even take out a negative cosine to deal with that now. Negative cosine x. When we take a negative cosine out of this one, what are we left with?
Cosine x.
Cosine x. When we take a negative cosine out of this one, what are we left with? Negative 1. Because I took out a negative cosine. Yeah. So then we've got negative cosine equals 0. So cosine x equals 0. And cosine minus 1 equals 0, so cosine x equals 1. Okay, so where is cosine x equal to 0? Pi over 2 and 3 pi over 2, right? Plus 2 pi n and plus 2 pi n. Where is cosine x equal to 1?
Zero.
0 and 2 pi.
Oh yeah, down here. Square root of 4 over 2 is 1.
And actually at 0 and 2 pi, we really don't have to list the 2 pi. We just say 0 plus 2 pi n. If I marked off that you didn't put the 2, I don't think this has happened on anybody's. If you wrote this as your answer, and I counted off, then I should give you a point or two. But I don't think that was anybody's problem. I think there were other problems on this problem. And we would say that n is a member of the integers.
This is an integer base.
Bam. Any other questions from the test?
Can we do like number 2, I think?
2. Sure.
Or did I get the hypotenuse wrong?
I don't know. You may be in the wrong quadrant. It's entirely plausible.
Well, when I was doing the Pythagorean theorem, you were a switchy line between b squared and c squared.
Some of y'all on one, was this the one? No. On, yes. No? What? Wasn't that? On one of them, some of y'all didn't reduce. You had the square root of 8, which should have been the square root of 2 over 2. Was that y'all or am I thinking of something else?
I had something like that. It was on 11 though.
Yeah, on 11. Yeah. So, number 2. We find cosine and sine given the cotangent is 3/8 and secant is less than 0. Cosine and sine. We are given that cotangent equals 3/8 and secant is greater than, no. Again, no. No's on top of no's is less than 0. So, secant is a reciprocal of what? Secant is a reciprocal of what? Cosecant. No, cosine.
Yeah, that's what I'm.
You're going to get there eventually. One of the C words, right? Right. So the signs, SIGN signs, of the reciprocals follow the primaries, right? So where is cosine negative?
On quadrant 2 and 3.
True enough. 2 and 3. It's one of those. So here's trickiness. What is cotangent?
Cosine over sine.
It is cosine over sine, less useful at this point. It is also
Tangent.
1 over tangent. It is also what? X's, Y's, R's.
Okay, which one is what? Sorry.
Cotangent. What is cotangent?
Tangent. It would be x over y.
It would be X over Y. It's positive. So how could we get a positive 3/8 out of quadrant 2 or quadrant 3?
They're both negative.
If they're both negative. So it's in quadrant 3. So So negative 3 and negative 8.
Yeah, sure.
Okay, so now we got to find our hypotenuse. Negative 3 squared plus negative 8 squared. It's always going to turn out positive. We don't really care about the negatives at this very moment. We will again here in a minute. Equals r squared. What's 3 squared? 9. Great. What is 8 squared? 64 equals r squared, so r squared equals 73. R equals plus or minus the square root of 73. It's r, so we chuck out the minus 1. So this is the square root of 73. So this is, I'm thinking it was on yours, B, where yes, it is cosine over sine, but you lose the square root of 73 if you, because like if we were dividing them, that square root of 73 would cancel, which is what, so it's kind of missing information. That's what I meant by missing information on the answer. So we're supposed to find the sine. So the sine would be square root of 3, negative 3 over square root of 73, right? The sine would equal negative 3 over the square root of 73. We got to rationalize, right? So that would be the sine of theta would equal negative 3 times the square root of 73 over 73, right? Cosine, same thing, but with negative 8, because it's adjacent over hypotenuse. Easy money.
Number 1. Well, I don't need to do the whole thing. Can you tell me what you were trying to tell me here? You circled that, and you were like, that's that, and you were like...
This is cosine. Because it'd be 1 over, it should, I don't know where you got 3 over the square root of 10. I don't know why you wrote this equals this. So I don't know exactly what you were thinking about it, but like cosine would be 1 over the square root of 10 because it's adjacent over square, and then which would rationalize into the square root of 10 over 10. And
I don't know where, I think I was thinking that, and I wrote it 3%.
so secant would be 10, square root of 10 over 1, which would just be this. So I don't know.
I don't know what I did.
I don't either. So, but that's what I was.
Where did 3 come from?
Well, the 3 is there. The 3 is opposite, but you don't need opposite for any of the ones you're trying to find.
Between opposite and adjacent.
Maybe.
Except for I got that one wrong.
Yeah, so I don't know. Anyway, I don't know. Okay. Anything else? No? Great. 3. 3 is easy, but I think you were trying to do some strange magic, if I remember correctly.
Yeah, I think start out at number 3.
I don't know. Did you try to get a single fraction on the left? Because that's what you should do.
Trying.
Okay, well, then you had the right idea at least.
When I got to this first single, the very first time I got to a single fraction, you went the big X. So I don't think my single fraction was right.
You do the, like, not butterfly method, but you multiply the denominators and then...
Equals
I don't know what I did.
2 cosecants. Okay, so we want to get this as the same fraction. So we would multiply this one times 1 plus cosine theta over the same thing. And this one times 1 minus cosine theta over the same thing. So the denominator is going to be this times this. These are conjugate. So the outside inside is going to cancel. So we just do the first and the last. The numerator, we can go ahead and distribute some stuff out. So on this one, we've got the sine of theta plus sine theta cosine theta. And then this one we've got plus, one is sine theta minus sine theta cosine theta. That's still supposed to equal 2 cosecant somehow. And then in the denominator, 1 times 1 is 1. And then we've got negative cosine squared theta. What's going to happen in the numerator? Yeah, the sine cosines are going to cancel. So, and then the sine plus sine is 2 sine, right? So we've got 2 sine theta in the numerator. That's where the 2 came from. Now, the denominator, what happens to him?
It becomes a sine squared.
Sine squared theta. And then a sine cancels with one of the signs on here. So we've got 2 over sine. And then Bob's your uncle. 2 over sine equals 2 cosecants. Let's look at today's homework for at least a couple minutes. See where we can be. Okay, we did from 6-1, 2 through 32. It's just elimination with matrices instead. Number 2 is -3, 1. Number 4 is 1/3, 1/4. 6 is 1/8, -1, -2. 8 is 5, 1/10, 4. 10 is matrix -4, -6, 25, 7 to 16. 12 is the same thing, augmented matrix, 4, 0, -1, 27, -8, 7, -6, -35, 12, -3, 5, 20. 14 is the augmented matrix, 0, 14, -2, 3, -22. 5, -4, 0, 11, -8, 2, 0, -6, 3, 15, 3, 7, -1, 0, 1. 16 is yes. 18 is no. 20 is no. 22 is in the appendix, but not my appendix. Well, let's see if the book agrees with you. $22 is 3, 0.5. 24 is -11, 3. 26 is 1, 2, 4. 28 is 24, -13, -18. 30 is cappuccino is $3.50, a latte is $4, and a macchiato is $4.20. Why they couldn't just look at the menu, nobody knows. But, you know, whatever. Number 32 is 151. Where do we have questions on that set?
Yes.
22 and 2. All the 2x2 matrices, the ones you're like, why can't I just use substitution?
Sadly use the statistical equation triangle for the Gaussian elimination, and I don't know how to do that. And I tried following the book, and it gave me stupid fractions.
Yeah, I got 182
So, 22.
over 53 and 419 over 424.
Yeah, sounds like what I got.
Equals -10y plus 11 and -8y equals -9x plus 23. Now we're supposed to solve this using Gauss-Jordan elimination. So, what do we need to do first? Yeah, we got to get it into a format that we can actually put into an augmented matrix. So we'll add 10y on the top one, plus 10y, and plus 10y on the bottom. We'll add 9x plus 9x. So we'll have the system 2x plus 10y equals 11 and 9x minus 8y equals 23. Now what?
I do not know.
Well, we should probably put it in an augmented matrix, right? That's like what we do to solve these problems.
I was trying to solve it like an augmented matrix without the augmented matrix.
Ah, well, that would just be like regular elimination, right?
No, like I did the same thing. I just had all the extra stuff in it.
I see. 2, 10, 11, 9, negative 8, 23. Ba-ba-ba-bum-bum. What should we do? Let's multiply the top one by a half. Turn that first one into a 1. Seems reasonable, right?
No, because you're trying to get the ones across the.
Yeah.
Okay.
Oh, so we're doing, what's it called?
We're doing what the whole lesson was about.
Row echelon?
Yeah.
It doesn't say row echelon.
It said using Gauss elimination, which is what that is.
Didn't put those things together.
I don't know why not. But here we are now. Now what?
1/2 times row.
That's a -8 on a -9.
Now what?
Multiply row 1 by -9 and then add it to row 2.
Yeah. Do -1 times row 1 plus row 2 and put it into row 2.
Why are you only multiplying it by -1?
I don't know. How about -9? That's what I meant. 5, 11 halves. This would be a 0. -9 times 5 is -45 plus 8 is -53.
-53? Sorry, I didn't say 11.
What's -9 times 11 halves?
99 halves.
-99 halves. What's -99 halves plus 23 halves?
122 halves.
-76 halves.
Oh yeah,
No, I got it wrong.
Wait, it's gonna be
Oh, yeah, -99.
54.
53
-53 halves. Now what?
I want that -53 to be a 1.
I think that's a great idea. Try to make that -3 a 1. So what should we do? It's not so scary.
Yes, it is.
Not really.
It wouldn't help to multiply the top one by 11 because that would get it to be 2 at the bottom.
Can't we just do that?
Sure.
Multiply it times -1/53, and then this is a 1.
That's a bunch of random crap.
And then it's also going to like clean this one up a lot, right? Wow! It's almost like the book planned it out.
What is it? 1/53?
Yeah.
Cool.
Now what?
Isn't it just
Well, it's so pretty.
No, because it's going to be 0. We're almost there.
Then we just multiply the bottom one times 5 and then add it to the,
-5.
yeah, -5 and add it to the top one.
Oh, is it
-5 times row 2 plus row 1 into row 1. It's almost like it was planned out. This one's a 1. This one's a 0. Negative 5 times 1/2 is negative 5 halves plus 11 halves.
Negative 5 halves.
So 3.
6 halves, so 3, yes. Wow. It's almost like there was planning and forethought.
I figured out why this works.
Well, good.
Because if you have 1 in every row, then you basically just solve.
Yeah, that's well, good. I'm glad. I'm glad you're catching on to the what's going on here.
We do number 2.
We can. I'll guarantee you it's not any harder than this one. We certainly can look at it.
I don't know, I can't seem to comprehend it for some ungodly reason.
Do you comprehend this one now?
Finally.
Well, then you probably understand 2, but we'll double check. Shall we?
I got
Oh.
right. Did it by elimination.
I got 2 right, but for the wrong reason.
Numero dos. We've got 4y. Yeah, we do have to do stuff, that's true. Plus 17 equals negative 7x. And 8x plus 5y equals negative 19.
We gotta get the 4y on the other side.
We do got to get the
Why?
So that the x's and y's are on the same side.
Should we just put the negative 7x on the other side and keep the y there and put the 17 on the right side?
You could do either one of those things. Either one will get you the answer. But if we do move the y, then we only have to do one thing. But you'll get the same answer either way, yeah?
You'll just have to multiply by negative 1.
You don't even have, they don't have to be positives. That's not in the rules. It might make us feel better about our lives, but they don't have to be. Oops, 7x minus 4y equals 17. What should we do now? Augmented matrix.
Oh, I just wasn't using it.
Good. Now what?
Multiply.
The bottom one by 1/5.
What? The bottom one by 1/5.
Pause, I wrote something down wrong. Wait, or you wrote something down wrong. Yeah, wait. Oh, you have it reversed. Okay.
I have the x as the lead, as the first
Well, you have
row.
them upside down from what I.
Oh my gosh, cholesterol. Yeah, multiply it times an 8. That sounds good. So this is 1, this is 5/8, and this is negative 19/8. I turned that into a 1. And then we could multiply 7 times the first row, add it to the second row, and put it into the second row. Right? So this would turn into a 0. What is 7 times 5/8? Because then when we add it to this, it's a 0. So I restate. What is 7 times 5/8?
35.
8s. 35/8 minus 4 is what?
3/8.
Somebody else agree? Probably, maybe. 35/8 minus 32/8. Wow, okay. And then what is 7 times 19/8? Negative 19/8.
133.
Eighths. Negative 133/8 plus 17.
What was the question?
We did 7 times this, and then we got to add it to 17.
14. So 7.
It's what now?
14/8.
Great. 14/8. Now what should we do?
Multiply. I'm just kidding.
How about we multiply row 2 by 8/3? Right? Because wouldn't that make a 1? 8/3 times row 2.
Can't wait till we get to learn how to do this. Like how today.
I figured it out the other day.
1. So that'd be 14/3 over here. Does that sound right?
On the test, are we gonna have to solve one by hand?
Yes.
Great. Seven.
And we can just multiply row 1 by 8/5.
That'll turn into a 1. We want it to be a 0.
So we'll multiply the bottom one times negative 5/8.
Negative 5/8 times row 2. Add it to row 1 and put it into row 1. One and then 0, and then what is negative 5/8 times 14/3?
$35/12.
35/12 plus,
Negative 35/12.
no, positive. Oh, you're right. You're right. Negative, whatever you said, plus negative 19/8.
So just addition.
Jays.
Negative 13/24.
Negative 13/24. Something, we made a mistake somewhere.
Negative 35/12.
That was the first one.
Yeah, and then we added the 19.
Did you get that in yours too?
I didn't.
We made a mistake somewhere.
Did I just
Plus.
plus 19/8, right?
See if we can track it down. Yeah,
Wait, what is the answer?
like negative 1, 3 or something. I don't know. Negative 3, 1. Yeah. So let's see.
Two was easy.
Did we? It is. We made a mistake. Mistakes don't mean it's not easy. Problem we did in Algebra 2 earlier today was hard. This is not hard. We just made a mistake. Let's see. Make sure we copy the problem down right. 14y plus 17 equals negative 7x. 8x plus 5y equals negative 19. Great. We copied everything down right. We subtracted 4y from both sides. And we got negative 7x minus 4y, and the first one's still 8x plus 5y, and that equals positive 17, that equals negative 19. So we did 8, 5, negative 19, negative 7, negative 4, 17, multiplied by 1/8, then you got 5/8 and negative 19/8. Then we multiplied 7 times here and added that to that. Positive 7. 7 times 5/8 is 35/8.
Yes.
35/8 minus 4 equals 53/8.
I'm getting 3/8.
Yeah, that's what I got.
That's because I wrote 85/8 for some reason. 35/8 minus 4 equals 3/8, which is what we wrote. And then times row 1, so 7 times negative 19/8, so negative 19/8 times 7,
Negative 130.
times 7 plus 17 equals 3/8, and we wrote 14/8 for some reason.
I got 3/8 too.
So that should be a 3/8, which already looks like a much easier circumstance. And then we did 8/3 times this one. Negative.
Doesn't that make that row 1?
Oh, times row 2. I was so confused. This should have been a 3/8. No. 8/3 would make this a 1. Yeah. So then negative 5/8 times row 2. What's that? So that's all correct. I'm not changing that. That's a 1, which is good because that's what we want it to be. Negative 5/8 times negative 19/8 is going to be something stupid looking. Oh no, negative 5/8 times 1. Negative 5/8 times 1 is negative 5/8. Negative 5/8 plus negative 19/8, which is negative 24/8, which is also negative 3. Okay, so you will, I need to state this because because I don't want you to just not study it at all. Now, I guess you could still get most of it, because I'll grade it the same way I grade the other one with systems. If you do it the wrong method, you'll still get most of the points, but you won't get all the points. But, and so if you want to kind of YOLO and hope for the best and whatever, or just check your work, what you are looking for in your calculator in order to just do this method on the calculator is you're looking in the matrix menu, or probably the matrix menu, or possibly in the stats menu somewhere, and you're looking for a button that says this. You're looking for something that's reduced row echelon form. You also need to figure out how to put this into your calculator. So you need to be able to put the matrix in there, which will be in the matrix menu for sure. And then somewhere, also probably in the matrix menu, there will be a thing that lets you turn this into reduced row echelon form, and you'll spit out the answer to a thing. And so everything after this, you'll always be able to check your work, at least, using your calculator. You'll still have to use the other methods to solve systems and all that kind of stuff.
So where's for homework?
There's a data matrix part.
Yeah, that's probably what you want.
So
But you said you accidentally figured it out.
So for homework for figuring out how to do it.
Pretty much, yeah, because we'll cover the next thing in class, next class.
open.
So goodbye, go away. And if you can't figure it out at home, your homework is to go to YouTube and you search RREF and then your calculator model. Well, you got to be able to put the matrix in there. There you go, you did it. I shall see you on Thursday.